Hello everyone, welcome to this first module of this Advanced Reinforced Concrete Design course. In this module, we will talk about what is prestressed concrete, what are the applications of prestressed concrete and so on. This is the expected learning outcomes. The student, after understanding or going through the video of this first module, should be able to explain the basic concepts of prestressed concrete and should also be able to explain the history of prestressed concrete. We will also talk about internationally how the prestressed concrete evolved and also in India how prestressed concrete evolved over a period of time. And we will also spend some time on through an example, why do we really need to prestress concrete, right? And we will also discuss the advantages of prestressing over reinforced concrete, especially the prestressed concrete in variety of applications using an example. I'll explain that. And then finally, the student should be able to also explain what are the applications where prestressing will be helpful in designing a more elegant and efficient structural element. Okay, so first and foremost, this is a design course, so we have to follow certain design codes. In India, the codes of practice are typically developed by Bureau of India Standard, and for prestress, currently we have IS 1343-2012, which is the current code of practice. And as you all know, IS 456-2025 draft version is in circulation, which is going to combine both reinforced concrete as well as prestressed concrete design aspects. Briefly, we will talk about how this code is actually addressing prestressed in design. And with respect to loads, again we will be following IS 875 parts 1 to 5 and how to take the design loads. We will predominantly take from IS 875, so which we will use it. And we will also use some special publications like SP24 and SP34, right. Again, with respect to road bridges, we will be following Indian Road Congress publications, which is IRC 112-2020, and we will also follow for prestressed concrete load design criteria. We will be following IRC 18. And there is also special publication from IRC, which is SP65, which is for design and construction of precast and cast in situ segmental construction. So, we will also use some of the provisions of that. And then, as explained in the introductory module, if you are designing a prestressed concrete bridge for a railway application, then we have to follow, particularly with respect to the loads that what we need to consider, we have to follow IRS concrete bridge rules, which was again reaffirmed in 2014, which is currently the standard for taking practice for using plain reinforced and prestressed concrete for general bridge construction for railways. Okay, so this is the broadly the codes of practice that we will be following in this course. Again, in addition to that, there are also several miscellaneous codes are available. For example, if you are using high tensile steel bars in prestressing, we have to follow this IS 2090 standard. The bars that what we are using should conform to the standard. Then for precast prestressed concrete steel lighting poles, if you are using for prestress, then you have to follow this IS 2193-1986 standard. And for prestressing applications with respect to liquid storage tanks, particularly for water tanks or some other liquid containing structure, then we follow IS 3370-2021, particularly for prestressed concrete we will be following this part 3 of this standard. So, that will also be used. And then if you are using for special applications indented wire, in prestressing steel there are different types of prestressing steels are commonly used, which we will again talk about it in the coming modules. but if you are using wire for a pre-stressing applications, then we have to follow this IS 6003/2010, right. Then we also follow, if we are using stress relieved strand, which is not very common these days because we will be using low relaxation strand, but for some reasons if this is being used, then you have to follow this IS 6006 standard for design. Okay, with respect to textbook, I think we have briefly talked about it in the introductory module. Again, these are the two common textbooks that can be used for pre-stressed concrete design. One is by Professor Krishna Raju. Currently, the 6th edition is available, so you can use it. And then there is also pre-stressed concrete design by Professor N. Rajagopalan. That also is a good material. I think you can use it for your references. But most of the other applications, I have taken a lot of material from the references that are listed below here. One is a very popular book, particularly in North America, which is by Professor Collins and Mitchell, which is on pre-stressed concrete structure design, and lot of material for this course also we have borrowed it from this very nice textbook, a very nice book which is on pre-stressed concrete. And then we also have a nice book on pre-stressed concrete by Edward Novi, and then the final one is on by pre-stressed concrete design from Nielsen. All three of them are fantastic resources. If you want to learn more about pre-stressed concrete other than the material that are covered in this course, you can use them for further reading. Okay, now let's get into the introduction to pre-stressed concrete. Particularly, we will talk about the evolution of history of pre-stressed concrete, what are the advantages of pre-stressed concrete, and what are the variety of applications of pre-stressed concrete. So, that would be the focus of this module. Right. So, what is pre-stressing? Pre-stressing is a process of preloading the structure as stated here, right, even before any external loads are applied. You are going to preload a concrete element in such a way that it is going to improve the overall general performance. So, now how do we do that? We know that concrete is strong in compression, right? It is strong in compression, right? But it is weak in tension. That is the fundamental aspect that we need to keep it in mind. So, for a typical element, if I take a cross section like this and if I look at the stress states, you get for a typical concrete element, because of the nature of the loading, I am going to have this kind of a stress profile. I will have tension at the bottom and I will have compression at the top, because it is a sagging bending moment. It is bending like this, right. So, you create a bending moment like this. So, you are going to have tension like this in the bottom and then compression, okay, at the top, right. So, you develop compression and tension, but concrete usually tensile strength is about 10% of compression strength, okay. So, it is a material which is having low tensile strength. So, if I keep increasing this external load, if it keeps going up, at certain load the stress at this bottom fiber will reach its tensile strength, then it will crack. Now, if this element is not having any reinforcement, then the crack will propagate quickly and it will lead to the failure. Now, our idea in pre-stressing is somehow if I can apply a load like this, right, and pre-stress in such a way that I create even before this external load. This is an external load, right. This is an external load, So, even before this external load is applied, if I can somehow create this kind of a compressive stress at the bottom, then when I am applying the external load, the load has to reduce all this compression and get into tension before it cracks, right. So, that is the whole essence of pre-stressing. because concrete is being weak in tension, we are trying to preload the concrete by applying compressive stresses either through pre-tensioning or post-tensioning, so that it is going to take more load before it can reach tensile strength of the concrete at the bottommost fiber, for example, for the given loading in this case, right. So, that is why I say here in this example, if you see, there is no external load, but still it is like I have applied a load exactly opposite to that of what I am going to get from here, right. So, that is the point, because if you see here, this particular beam has deflected like this. So, that is what we call that as a camber. So, I am going to create compression at the bottom and tension at the top by applying a pre-stress, so that under external load, that is going to offset the tension stress that is going to come from external load. So, that is the whole idea, right. So, this is a very classical example of where the pre-stressing is used, and you can see that this kind of a wooden barrel in the olden days people used to use for storing material or liquids, right. And due to the hydrostatic stress, right, you will create hoop tension. Now, the wooden staves like this, these are all individual wooden staves, right, and they are all connected together by this metal band. Now, if the liquid storage is creating more internal pressure, then it can separate these elements out, right. So, and then it can lead to leakages. So, now what people do in the olden days is they heat this metal band and then they force fit all the individual wooden staves together, so that even when you store the element, the individual pieces cannot separate from each other. So, that is the very nice example of pre-stressing. Even before you put anything to any material inside for storing, you have actually created a pre-stress and not letting that wooden staves to separate from each other, right. And this is a typical case. You have a radial pressure that is generating from the material that is stored in this wooden barrel, that is going to create this kind of a tension, right. This kind of tension that is going to create, and that tension has to be counteracted by applying a pre-compression. So, that is the application, the earliest applications of pre-stressing in the case of a wooden barrel. Okay. Now, another important application is here all of us have used bicycles, right, and bicycle wheel is associated actually with application of pre-stressing. Okay. Now, you can see here actually the load actually comes to this, right, through the fork, and then if you see here, we know that steel exactly is opposite. Steel is very good in tension, right. Steel is very good in tension, but under compression steel will buckle, right. So, steel members, especially for example, if you see the spokes, right, these spokes are all very thin elements. Thin elements, you know that they are more susceptible to buckling. Then how do we transfer the load from the fork to the ground? So, the whole idea is in any structural system, we have to transfer the load safely to the ground. Now, you see this is the point of contact, this is where all the spokes are getting connected, right. So, if this element, if it is going to be compression, the spokes are also going to be in compression, and the spokes are all very thin element, right. Now, because by the width of thin element, they are also quite longer, the slenderness ratio is going to be high, right. So, we should not let this thin spokes to get into compression. So, basically what is that we do? We try to reduce the compression by applying lot of tension, right. So, that is what we do it in spokes. You must have gone to your cycle shop. Typically what they do is they take a small element and then they tighten these spokes, so that they are always in tension, they will never get into compression, right. So, that is what we say, we tension the spokes. So, the rider's weight is actually carried by from the forks to the ground, actually by the bottom spokes, by reducing the pre-tension levels in the lower spokes. In fact, actually only couple of spokes are actually carrying the load at any one point of time, because the wheel is actually moving on the move. So, only maybe some very few spokes are going to be transferring the load from the fork to the ground. Okay. This is again another very interesting applications of pre-stressing. So, pre-stressing is not always because concrete is weak in tension, so we put compression. But here in this case, if you see, the spokes are weak in compression. So, what we do is we apply more tension, so that even when compression is coming, it will still be in tension, right. So, that is the idea. Now, let us get into the concept of pre-stressing. This is a very elegant example of illustrating the benefits of pre-stressing. So, you see here in this illustration, you have stack of books that are being kept hold, and then we are actually applying a pre-stressing, right. We are applying actually a pre-stressing, right. So, if you see here, the books on the bottom are like pre-compressing the concrete. If you do not have this pre-compression or the effect from by squeezing these books, then it cannot really take this load, right. So, then the books will separate each other, right. So, but if I squeeze this bottom stacks of books, then I can apply load onto that. That is exactly what we do to concrete as well. We, by the virtue of pre-stressing, we make sure that the concrete is predominantly going to be in compression, because concrete is strong in compression, so it can take more loads. Okay. So, not only by the virtue of this compressive force, they are not only supporting their own weight, but they are also supporting significant amount of superimposed loads represented by books on the top. In fact, this is a very famous example. It was originally illustrated by Professor Gustav Magnell from Belgium. He is one of the pioneers in promoting the applications of pre-stressing. Okay. Now, why do we really need to go for pre-stressing? So, our objective of pre-stressing is basically concrete does not want to be in tension. In fact, concrete, if you are preventing the concrete from cracking, then you are basically improving the durability of the concrete. So, our idea of pre-stressing is to either control or eliminate the tensile stresses in the concrete, okay, at least under service loads. Of course, when the load levels are getting higher to the level of ultimate load, then the element has to crack. But under service loads, we want to make sure that the tensile stresses are kept very minimum, so that they are not going to crack. So, that is the whole essence of pre-stressing, or we can say control or eliminate also deflection at some specified load level. Again, deflections, deflection is related to the curvature. If you have more cracking, you will have more curvatures of the sections, then you will have more deflections. Again, if I am able to limit the cracking, then I can also reduce the deflections under service loads. Now, again, objectives, again, pre-stressing allows us to use high strength materials like high strength steel and high strength concrete. Okay. So, with use of high strength steel and high strength concrete, we can come up with very efficient structural design. So, that is a very another important nice aspect. So, you can see this is a very nice bridge, which is a Durgam Cheruvu bridge located in Hyderabad. This is an extra dose bridge. It's called extra dose bridge. Okay. And all the bridge decks, if you see this bridge decks, they are all segmental boxes and they are all pre-stressed. Okay. These are all segments. They are connected and pre-stressed together by high strength steel. Okay. So, like this we can design and construct a very elegant structure by applying pre-stressing. So, we can also achieve economy, because again at the end of the day, design is not only about safety, durability, also the design should be economical, right, and that should lead to reduced maintenance and longer lifespan. That means more durability. So, now as we have seen, concrete, if it is crack free, then the durability will be better. So, which we will talk about it again in the coming parts of the lecture.